Good morning everyone, so welcome to the Incredible Power of Indices, where we're going to be practicing the rules of negative and fractional powers. Got a little bit bored of worksheets, so I thought we'd have a go at doing it this way. So the first thing I'd like you to do is write down all these problems that we've got here, pause the video and have a go whilst I crack into me chocolate hobnob. When you've finished, roll the tape and see what your answers should be. The first rule then is that you add your indices as you go. Now if the question was asking you to leave it as a power of 2, it would just be 2 to the power of 5. But because it says evaluate, you've got to work out what that is. So 2 times 2 times 2 times 2 times 2, which is 32. 2, 4, 8, 16, 32, 2 to the power of 5. Now, a new rule: when we've got a bracket, we multiply them, because if you think about it, that's going to mean that we're going to times that by itself that many times. So 2 to the power 3 squared is the same thing as saying 2 to the power 3 times 2 to the power 3, which gives you 2 to the power 6, and 2 to the power 6 is 64, because that's double your 32. So our rule there is that a to the n all to the m gives us a to the n times m. Third one, negative powers. Now this is a little bit of a strange one. It all happens because the opposite power, when you're dividing, you take powers. So if we'd had 5 divided by 5 squared, that would give us 5 to the minus 1. Well, 5 divided by 25 would be 1/5, which is where we get the third rule from, that a negative power is the same as 1 divided by the same thing to the positive power. So you put it into a fraction over 1 and turn the power to positive. So that would give us 1 over 5 cubed. But then because we're evaluating, we need to make sure that we've worked out what 5 to the power 3 is, and 5 to the power 3, 5 5s are 25, times 5 is 125. Watch out for any mistakes, by the way, folks. Last time I did something like this, the wonderful world of whatever it was, surds, I believe, I seem to remember claiming that 10 was a square number. Obviously that was not true. Now the next one I'm not going to is, well, actually we will put it down as a rule. I reckon you're all going to have remembered this. Anything to the power 0 is 1, and that comes about because if you had a number of powers and you divided it by itself, so if you had 5 squared divided by 5 squared, according to our indices rules, you take the powers, so 2 take 2 is 0, and that's actually 25 divided by 25, isn't it? Anything divided by itself is 1, so 1, what we should have had there. On to fractional powers. So fractional powers come about because if you had, let's say 8 to the power a third times 8 to the power a third times 8 to the power a third, that would give you 8 to the power of 1/3 plus 1/3 plus 1/3 makes 3/3, which is 1, which is just 8, isn't it? So this number must be the number that times by itself, 3 of it times by itself would get you to that. Well, that would have been 2, wouldn't it? And the cube root of 8 is 2. So a power is like a fractional power is like a root in effect. So we can put down our next rule on that, of saying that if we had a to the power of 1 over n, that's going to give us the nth root of a. How does that translate down here? That translates to the cube root of 1000, and the cube root of 1000 is 10, because 10 times 10 times 10 is 1000. When we get to a fractional power, we've got the numerator is your power, your denominator is your root. So I think we're going to need to have a little bit more room here for a couple more rules. So I'm just going to take this bit out now. So our sixth rule is going to be, if we've got a to the power of n over m, that's going to be the same thing. What you want to do is you can power it up and then root, but then you get a much bigger number, which is harder to deal with. So what we do is we do the root of whatever the bottom number is. When we've worked that out, we do that to the power n. So for this, we would be going cube root of 27, whatever that is, squared. Well, the cube root of 27 is 3, so it's going to be 3 squared, which is 9. And the final one, when you've got a negative fractional power, so look like a to the negative n over m, you simply say it's going to be 1 over a to the n over m. So you still do the same thing, you just divide 1 by it, but you make it a positive power. And that's going to give us 1 over the fifth root of 32, all to the power of 4. Now we were doing powers of 2 earlier, and 2 to the power of 5 was 32, so that's going to be 1 over 2 to the power of 4, and 2 to the power of 4 is 16, so it's 1/16. Now if any of that confused you, I recommend rewinding through and watching it again, just the little bits that you haven't got, until it starts to make some sort of sense. Anyway, I'm going to keep all the rules up here and put some other slightly different situations for you to have a go at. Right, so here's 3 more problems for you to have a go at. You can do it all, but you're going to have to use a little bit of your own initiative as well to have a go. If it goes wrong, don't worry. Pause the video. And carrying on. So when you're going to do the square root of something, it kind of comes about because when you multiply fractions, you times top and bottoms by each other. That when you do the square root of a fraction, you can not only first of all say that, but you can also say, if you find the square root of the numerator and the denominator, that will get you there. As the square root of 16 is 4 and the square root of 25 is 5. If you think about it, 4/5 times 4/5 is going to give you 4 4s are 16 over 5 5s are 25, isn't it? So there we go. On to the next, 32 to the power 0.4. Well, you need to turn that to a fraction, because I haven't given you any rules for decimals, have I? That all gets a bit confusing. 2/5 you need. 4/10 is going to be tricky because I don't know what the 10th root of 32 is. It's going to be a third. So we need the 5th root of 32. 2 to the power 5 is 32, so for that reason that is 2. So we're looking at 2 squared, which is 4. And you will notice in these questions the same numbers come up time and again, like 32, 64, 128, 125, and all of that jazz. On to this one. So 25 to the power half, that is square root of 25, isn't it? And I think it's helpful just to write what that is rather than trying to work it out every time. Negative power means we divide 1 by it and turn the power positive. So then we can say, I know the square root of 25 is 5. And we're going to be dividing by a quarter. By the way, you don't need to worry about the positive and negative things on this. Those are actually there as possibilities, but they don't expect to see it. So we're doing 5 stage change, flip. 5 times 4 over 1 is the same as 5 times 4, isn't it? So that gives us an answer of 20. All right, we'll move on to 3 more. Right, here's 3 more problems showing you how these can all be like sort of done slightly differently, so to give you a bit more experience. So pause the video, do what you can, take each bit one little bit at a time. So 125 to the power a third, that means the cube root of 125, doesn't it? And 2 to the negative 3 means 1 divided by 2 to the positive 3. The cube root of 125 is 5. 2 to the 3 is 8, so we're looking at 5 times 1 over 8, which is 5/8. You can turn it into a decimal, but there's no need. Right, so first thing to do is turn this into a top-heavy fraction. 1/2 is 3 over 2. We know anything to the power 0 is 1, so I'll get that bit out of the way. So to the power 3 over 2, well, the 2 on the bottom means square root, doesn't it? And then that'll be done to the power of 3, and we'll add 1 to that. The square root of 16 is 4, so we're looking at 4 cubed plus 1. 4 cubed is 64, add 1 equals 65. Right, the last one over here. It may surprise you to know that you can just flip it over to the reciprocal and make it the even power. And the reason for that is we said that it was going to be 1 over, didn't we? 49 over 100. And you may well have done something like this. But what that means is 1 divided by the square root of 49 over the square root of 100. And when you divide by something, you multiply by its reciprocal, don't you? You do stage change, flip. So it would be looking like that. So that gets us to this situation. So this, now we do just need to find the square roots of 100 and of 49, and that gives us 10 over 7 as our final answer. All right, so we're just going to have 3 more to have a go at, and then we're done for today. Right, so this is the last 3 examples I want you to have a go at today. So pause the video, take your time. It's all a little bit different to what I've heard before, but just try and apply something of what you know and see what happens, and then watch through. Right, so when it says 27 in the form 9 to the power n, the first thing you'll realise is that 9 squared is 81, so how can you get to 27? But you probably also realised 3 squared is 9 and 3 cubed is 27. So that's part of it. We could say that 9 equals 3 squared, but we could also say that 3 equals the square root of 9, or 9 to the power a half. And that's the key, because it's 3 that you want to cube to get to 27. 3 cubed equals 27. Therefore, 9 to the power a half cubed equals 27. And you've kind of done it there, but really we should then expand that bracket to give us 9 to the power 3 over 2. Next one, we've got to do the quad root first of all, haven't we, and then cube, and treat numbers and letters separately. So the first thing I'm going to do here is I'm just going to say that's what I'm going to do. I'm going to put that quad root round all of it and then put a bracket round to say I'll cube it later. So 2 to the power of 4 is 16, so that will become 2. And what do we do when we're going through a bracket like that? You can actually divide the 8 by 4, because remember, you're looking for the number of x's powered that done 4 times would get to 8, and x squared times x squared times x squared times x squared is going to be x to the power of 8, isn't it? So that must be the quad root. So x squared, that all has to be cubed. Now when you do 2 cubed, that gives you 8. When you do x squared cubed, that's when you multiply the powers to get out of the bracket, isn't it? So that gives us x to the power 6, because x squared cubed is that, isn't it? Right, on to the last one. Now this one may have made you flip your brains a bit, or probably just say, no, I'm not doing that, sir. And I understand, but when you're taking powers, that means you're dividing, doesn't it? So we are saying we're doing 3 to the power x divided by 3 to the power y. So let's replace that with 9 root 3 divided by 1 over root 3. Now if you hadn't done this, pause the video and have a quick go now. When we're dividing, we do save change flip, don't we, to make it into an equivalent multiplication. So that gives us root 3 over 1. Well, we don't need the over 1 because that doesn't make any difference. And if you do root 3 times root 3, that makes 3. So then 9 times 3 is 27. Right, so I did say that was all for today. So I would like you to take a couple of pictures of something that you've done, the bit of work you've liked most, and show that to me. If this has taken you less than an hour, and it's possible that it has, or you've got a bit of extra time and you just love doing maths, I don't want to stress you out, you could always go to practice a bit more of this stuff, because there's lots of different forms that questions come up in, and then by all means send me a ask me a question about it if you have, or just upload some of what you've done. And where I'd like you to go would be the website I've been getting the our earlier worksheets from. So if you go to mathsgenie.co.uk and hit the tab for GCSE revision. Once you've hit that, you need to scroll down to grade 6. I think this is tougher than grade 6 myself, but hey, there you go. It is high old style grade B, grade 6, not to be sniffed at. So grade 6, if you go to there, then you should find a couple of different forms of the questions you could download for fractional and negative indices. I think it's the second topic on under grade 6, and there's also solutions there as well, so you can check your work, or you can just send it to me. Okay, great stuff folks, see you tomorrow.